Have you ever wondered what your friends are reading, or which books they have that they might be willing to lend you? Do you have a way to track your reading progress that you're excited to use? Goodreads allows you to track your reading progress, but the social features are really limited, and Storygraph has lots of statistics, but it's a very clunky and unfamiliar user interface. Introducing your solution, Bookworm, where reading becomes social. My name's Corinna Klinkenberg. I'm a data science student with a passion for using AI and ML to help people and the planet. To this end, I work with a company called Ecovia, building AI tools that help social workers accomplish their jobs better and removing inefficiencies in the company.
I'm Sam Krishnason. I'm a computer science student at the university with full-stack web application development experience with companies like Payit and the university's own atmospheric science department, with specific expertise in security and authentication.
Hello, my name is Nicole Forrester, and I'm a double major in computer science and applied mathematics. My experience includes solving mathematical research problems with code and creating automated scripts for companies like Northrop Grumman to save time and money.
My name is Riley Cran, and I'm a graduating computer science student at Yale. I've had internships ranging from startups to bigger companies, where I learned how to develop scalable React applications. I have a passion for reading and running, and apps like Strava help me keep in touch with my friends and hold me accountable for my running progress. I started to wonder why there was nothing like Strava for reading. They're both very individual activities, and I really value which books my friends recommend to me. That's why we developed Bookworm. Bookworm is a place where book lovers can connect. They can discover their next great read together, and they can track their reading progress.
Central to Bookworm is the social aspect. After creating an account or signing in, we can navigate to the search tab. We can see Nicole's bookshelves and latest posts by navigating between the tabs in her profile. We can find books powered by Google Books API and add them to our bookshelves. Our recommendation algorithm allows users to find similar books. Our post page has a chronological feed where we can see our posts as well as our friends' posts. We can like and comment. The data page on your profile shows a weekly breakdown of your pages read and a graph displaying your reading statistics. Earn badges by reading books, interacting with other users, and adding books to your bookshelves.
We developed Bookworm using React Native, an open source framework developed by Meta. We chose it because of our group's familiarity with React and the simplicity of having a single codebase that compiles to iOS or Android. Components can render incrementally as data streams in, allowing for a seamless user experience. TypeScript helps catch many of the pitfalls of developing in a JavaScript framework. It allows for things like self-documenting code and type safety. An important part of this project was the rigorous code review process we put into place. We put a high importance on things like scalability, which meant batching network requests whenever possible. In many cases, this led to 3 to 4 iterations on a code review before it got approved. In the end, this paid off because it allowed us to maintain code that had been written upwards of 8 months in the past.
We deployed our app using Expo and created custom hooks to standardize routing around the Expo router. This creates a seamless user experience, allowing users to navigate to distinct pages throughout all of our tabs. We also used TanStack React Query to enable efficient data fetching, caching, and synchronization across all screens.
To store user data securely, we use Google Firestore, a relationless database system that allows for ease of deployment and continuous modification. This allowed us to implement Google Authentication, which enabled us to focus on feature development early on instead of building an authentication engine from the ground up. The app also has user persistent storage, so it remembers who you are every time you sign in.
My main focus for this project was developing our recommendation API. which provides two endpoints. The first provides recommendations for a user based on all of the books they have in their shelves. The second provides recommendations for similar books using the categories and the descriptions of the books. The algorithm works by one-hot encoding the categories and using term frequency inverse document frequency, or TF-IDF, on the descriptions. Then all of the books in our search space are compared to the source vector using cosine similarity, and the top 10 most similar books are returned. Riley helped with the deployment of the API to an AWS Elastic Beanstalk environment. We use an SSL certificate to allow HTTPS requests from the app to the API.
To support our deployment and hosting costs, we successfully pitched Bookworm to Get Seated, a grant program that funds student ventures. The funding that we won has allowed us to maintain our infrastructure and grow our user base.
Over the course of the last year, we've successfully built a fully functioning social media application from the ground up. We've handled challenges ranging from user authentication, data persistence, recommendation algorithms, and cloud deployment.
We utilize a rigorous code review process with an emphasis on scalability that allows us to maintain our app as it grows.
We're proud of what we've built with Bookworm and the technical challenges we've overcome. We look forward to applying these lessons to our industry careers.
We're especially grateful to our teachers, Professor Feng Jiao Wang and Professor John Davison de Saint Germain.